Alright, welcome everybody to the second part of the DFS algorithm in Graph. Well, in this video we're going to implement the idea mentioned in the previous video, the idea of DFS. So here's a sample graph. We have this graph with 13 nodes from 0 up to 12. So basically here I have opened up code blocks and I have copied the implementation of the graph. So it's all there. And all we have to do is to implement the graph DFS function. And inside the main function here I have created a graph G, and then I have constructed the graph according to the diagram that I've just shown you. So connecting 1 to 1, 1 to 2, 1 to 3, 2 to 4. For the weight here, just random numbers, random value. You don't have to care about for now, okay? So after filling the graph, we have to call the graph DFS function in order to perform the DFS algorithm and traverse the graph in the way described in DFS. So we said that the first thing to do inside this function is to check whether the node U is already visited or not. If it's already visited, then we don't have to waste our time doing anything else. We just have to return. So if node U is visited, we're just going to return. Otherwise, if it's not visited, then we're going to make it visited. So it's visited now. And then we're going to iterate through all of the nodes adjacent to it, okay? So we're going to get a copy of all the edges that are connected to node U, or let's say that are outgoing from node U, and then we're going to visit all of the nodes associated with those edges. So let's create an iterator edge, which points to a linked list of the neighbors of the node U. So this get neighbor here will return a pointer that points to all of the nodes, all of the edges outgoing from node U. Okay. So now we know all the neighbors of U. Now all we have to do is to iterate through all of them. So let's iterate through the neighbors of U. So while E is different to null, remember this is a linked list, so we're just gonna traverse, we're gonna loop through the linked list the same way we used to iterate through the linked list in data structures. So while E is different to null, and then E here takes its next, and then for every iteration we're going to basically call graph DFS function on that neighbor there. So instead of calling graph DFS with U, we're going to call that with EV. And then of course we're going to have to give it the visited array there. Now let's compile, see if there's any compilation error. There isn't any. And now let's test this function. So of course we're going to have to create a visited array before calling the function, and this array has to be initialized and false. So I'm going to do this in the main program. So int I, and then we're going to create a visited array of size 13, since our graph has 13 nodes in it from 0 up to 12. And then I'm going to initialize, so for I starts at 0 up to 13, visited of I takes false. Now that we have the visited array initialized, created and initialized to false, the only thing we have to do now is to call the DFS function. And we're going to give it the graph J, and we're going to give it the vertex that we want to start with. Let's say, for instance, it's going to be 0. And then we're going to give it the vertex array visited. All right, now this will run, but it'll not print or show anything because we have not added any printing function. So this is basically the skeleton of a graph DFS. Okay. Now any code you want to perform here, you're going to have to perform it in this section here. Okay, before calling the function recursively. So anything you want to do with the node, whether you want to print them or do any more complicated stuff on them. So I'm going to simply print the node. Okay, so I'm gonna print here a decimal and a tab, and then basically I'm going to print the node. Well, you know what, let's print it here. Okay, let's print it here. So whenever we visit a node, we're gonna print it. Okay, let's do it here. It's a cleaner way to perform the operation. Okay, so you can either put it here after checking if that the node was not visited before and this is the first time visiting the node, or you can do it inside the while loop. I prefer really doing it here. It's cleaner and it's easier to maintain. So there we have a tab, and then here we're gonna print U. Okay, so let's compile and run. And as you can see, these are the nodes that we visited. So we visited 0, 1, 3, 7. So let's take a look at the sketch pad there. So here's what that's going to happen. We start, well, let's return. We start visiting, oh, come on. Okay, so we start visiting node 0 here, and then from 0 we visit its adjacent, which is 1, and then from its adjacent we're going to visit 3 here. You notice here that I started with 3 and not with 2 because the order of adding the edges in our implementation is always reversed. Okay, so if we add edge that connects 1 to 2 and then we add an edge that connects 1 to 3, then we would have the edge that is connected 1 to 3 first, okay, before the edge that is connected 1 to 2, because we're always pushing to the front of the list, remember? So we're going to visit 3, and then from 3 we're going to visit 7, and then from 7 we're going to visit 6, and then from 6 we're going to visit 5, and then from 5 we're going to visit basically 2, and then from 2 we have no choice but to visit 4. And then we're going to return until we get back to 0. And as you can see here, node 8, 9, 10, 11, and 12 are left unvisited. So we're going to have to put our graph DFS call function inside a loop in order to make sure that all the nodes get visited. So, and this is basically the order that we have just shown in the diagram. That's 0, 1, 3, 7, 6, 5, 2, and 4. So in order to make sure that we're going to visit all the nodes, all we have to do is just to put the calling of the DFS inside a for loop. So for I starts at 0 to the very last node, so that's to 13 exclusive, and then every time, instead of visiting graph and 0 as the starting vertex, it'll be I. The starting vertex is I. And as you can see, this is the order of visiting the nodes. So we visit from 0 up to 4, and then 8, 10, 12, 11, 12, and then 9. Okay. Cool. So that's basically the implementation of the DFS inside the graph data structure. Thanks for watching. See you at the next video.